Some have criticized me for starting all of my videos with the word okay. Please notice I started this video with the word some. Alright, here we go. I'm talking about the discriminant today. The discriminant is given to you in your formula packet. It is b squared minus 4ac, and we are referring to the standard form in a quadratic. And I also want to point out that in the quadratic formula, the discriminant shows up underneath our radical. So make sure it's clear to you that this is our discriminant. Okay, it's not the square root of b squared minus 4ac, it's just b squared minus 4ac. Now, why do we care about the discriminant? Well, it tells us about the nature of the roots. So without actually finding the roots, we can learn about them through the discriminant. So if you do your b squared minus 4ac, and by the way, we use this symbol, little triangle symbol, to represent the discriminant. So if our discriminant ends up being exactly equal to 0, well, graphically, this is what it would mean. You would have a situation where the parabola touches the graph in just one spot. So if the discriminant is equal to 0, we have one real and equal root. Now, why is it equal? Well, if we're going to have one real equal root, and sometimes by equal we mean distinct. Okay. If we look at, how about y equals x minus 4, x minus 4. Suppose we have a quadratic that factored into that. Well, if we were to set it equal to 0 and solve, x would equal 4. Well, notice how you would have two roots of x equals 4. So we say we just have one distinct or one equal root. Okay? So if you end up having identical factors, you end up with a couple solutions, a couple roots. Well, it's really the same thing, so we say there's just one real equal root. So expect that if your discriminant is equal to 0. Okay? So it's going to be touching the x-axis in one spot. So we have one real equal root anytime the discriminant is equal to 0. Next scenario, the discriminant is greater than 0. That means it's a positive number. Your graph is going to look something like this. Well, what this means is we're going to have two different roots. So we're going to have two real, now real as opposed to imaginary. Alright, in this course we only deal with real numbers. So we're going to have two real unequal roots. Okay, so two real unequal roots. Alright, so as illustrated by my picture here, you have a situation where you have two roots. They're clearly not the same. Okay, if the discriminant is less than 0, this is where you might have something like this going on. Now I'm drawing all of my parabolas opening upward. They could also open downward. Okay, so if the discriminant is less than 0, that means it's a negative number. That would mean you would have a negative underneath your radical back up here in your quadratic formula. You know you can't have a negative underneath the radical. So that would suggest we have no real roots. Okay, so if you were to calculate your b squared minus 4ac and you get something like negative 7, you know there are no solutions. Okay, no real roots. Okay, some further information. If our discriminant is a perfect square, alright, a perfect square, something like 1, 4, 9, 16, 25, 36, etc. If we have a perfect square like that, that tells us that our quadratic has two rational roots. So we're talking about the second case back up here where your discriminant is greater than 0. So if it ends up being one of these perfect squares, we could also determine that, you know what, we're going to have rational roots, which is the opposite of irrational roots. Okay, so just think about it. In your quadratic formula, if you had a perfect square right up here, if we had a number like 36, you'll be able to take the square root of it, and you're going to get a nice number in the end. All right, it might be a fraction, but it's going to be a rational number. Okay, so if we have a perfect square, we know we have two rational roots, which can be found by factoring. So this is often helpful. If you were to find your discriminant, your b squared minus 4ac, and it's a perfect square, you're not wasting your time trying to factor it. Okay, if you get something like 25, all right, I know it's factorable, I'm not going to be wasting my time. Whereas if you get 26, that's not a perfect square, so I'm going to have to use quadratic formula or a different technique. So here's an example. We're looking to describe the nature of these roots. We're not looking to actually find the roots. So if we do our b squared minus 4ac, my b here is really 1. It's really 1 in front of that x. So 1 squared minus 4 times a times my c. Be careful here. You're going to have 1. Now we have two negatives being multiplied together in this big cluster of multiplication. So that's going to give me a positive 48. Added onto that 1 gives me 49. So my discriminant is 49. Notice how it's greater than 0. So that's, and it's a perfect square, right? So that suggests we have, if we're going to describe the nature of the roots, that means you have to use words, all right, and write it out. So this would mean that we would have two real, rational, and unequal roots. Okay? So that's describing the nature of the roots. Notice that we did not actually find the roots. Okay? Our focus here is on just describing them. Okay? We're not going to worry about this last example 6. The focus is again on just calculating your discriminant, understanding that if it is a perfect square, such as what we have up here, you're going to end up with rational, real, and unequal roots, okay? And you'll be able to find it through factoring, okay? Goodbye.